Hi everyone, here is the video going over 6.5 trig form of complex numbers, day 1. So after you are done watching this video, you should be able to write complex numbers in trig form. So what is a complex number? A complex number is the a plus bi, and that complex number can actually be written trigonometrically where it would look like this. So r times cosine of theta plus I sine of theta, and this right here, r cis theta, is a shorthand version of this. Now, what does all of this mean? So in order to write your complex number in trig form, you need to know two pieces of information. You need to know what r is, and you need to know what theta is. R is equivalent to the absolute value of the complex number. Now, the absolute value of the complex number is going to be the square root of a squared plus b squared. And theta is an argument of your complex number, meaning that if you were to graph that complex number, what would that angle measurement be that has the visual representation of that complex number when you graph it? So once I have theta and r, I can go ahead and write my I can write my complex number in trig form. So a couple visuals to help you understand this a little bit better. Let's say I have the complex number 1 plus 2i. It's very similar to graphing the ordered pair 1, 2. So I would go to the right 1, up 2. And that right there is the geometric representation of 1 plus 2i. Now this side is 1. This side is the 2, okay, or in this case 2i for the complex number. Now what I want to do is I want to find the magnitude, which is actually the r, of your complex number. And that comes from taking this absolute value of your complex number. So absolute value of 1 plus 2i is going to be the square root of 1 squared plus 2 squared. So this ends up being the square root of 5. So that right there would be the r. And then for theta, theta would be this angle measurement inside your triangle, or depending on the quadrant that you're in. So we'll see this with several examples. Now, a couple things that I really want to draw your attention to, and I think I've actually already said it, r is the same thing as magnitude. So you heard me say magnitude when I was trying to find r, and then I switched to saying it was the absolute value. But it's the same idea as what you've been doing for section 6.3 and 6.4. So these two pieces of information, super important. We're still finding magnitude and direction, just like we did with vectors, but you're doing it in a different context of using complex numbers instead of vectors. Okay, so let's go ahead and do an actual problem. Okay, express the complex number in trig form for 0 is less than or equal to theta is less than 2 pi. So in order to write the trig function or the complex number in trig form, you need to know two pieces of information. We need to figure out what r is, and we need to figure out what theta is. Now, in terms of vectors, r was the same thing as magnitude, and theta was the same thing as direction. So as I'm solving these problems, you'll see me do them the same exact way that we did with the vectors. Okay, so here's my a. There is my b. So r is going to be the square root of a squared plus b squared. So that gives me the square root of 4 plus 4, which is 8. And you can go ahead and simplify that to 2 root 2. Or you can leave it as 8, whatever floats your boat. So that right there would be the same thing as finding the magnitude of a vector. It's just that for these complex numbers, we're going to call it r. And for theta, when we're trying to figure out what theta is, it is important that you actually graph your complex number. So I'm going to graph this just so I can have a visual. So -2, -2, that puts me in the third quadrant. And of course, we're going to have a lovely little right triangle, just like we did with vectors. And here is my theta. So I'm going to go ahead and find my reference angle. Once again, if I look at my triangle, I have the opposite and the adjacent, which means I'm going to use tangent. So I have tangent of theta equals opposite over adjacent, so -2 over -2, or tangent of theta equals +1. And since we're trying to find the inverse tangent, or since we're trying to find an angle, you want to do the inverse tangent. So I'm going to take the inverse tangent of 1, and that is going to give me 45 degrees. So my angle measurement right there is 45 degrees. Now the angle measurement that I actually want for my theta, also known as your direction, is going from your positive x-axis all the way around until you hit your complex number. So in this case, my 45 degrees is just this little wedge right here. It's your reference angle, but I want the entire angle drawn in purple. So I'm going to take 180 degrees plus the 45 degrees, and then that gives me 225 degrees. Now, anytime we are writing a complex number in trig form, we always want our angle measurement to be in radians. If you look at my directions, it says theta has to be between 0 and 2 pi. Now, I personally like to work in degrees first, and then from there, change it to radians, because that's just how my brain processes some of this stuff. So my 225, I'm going to go ahead and change that to radians, and in order to do that, I'm going to take 225 and divide it by 180 while putting the pi back in the numerator. So that gives me, I believe, 5 pi over 4. But, I'm going to plug it in my calculator because I don't trust my mental math skills. 5 pi over 4. Perfect. Okay. So now I have the two pieces of information that I need to be able to write my complex number in trig form. I have my r, and I now have my theta. Now, we're not actually at the answer yet, but we are just one step away. So what I'm going to do next is I am going to follow this formula, so to speak. I'm going to follow this to be able to write my complex number in trig form. So my r was the square root of 8 or 2 root 2, whichever one you want to use. So I have, I'm going to go with 2 root 2. I'm writing my answer at the top because I ran out of space on the bottom. So I have r times cosine of theta, which is 5 pi over 4, plus I sine of theta, which is 5 pi over 4. And this right here, ladies and gentlemen, is the complex number written in trig form. Now, if I go back to here, we also had a condensed version. That's this right here. So I'm actually going to write out that answer as well. So when I have root 2 times cosine of 5 pi over 4 plus I sine of 5 pi over 4, I can actually condense that answer to just 2 root 2 CIS. That CIS stands for the cosine plus I sine. Okay, it's just a condensed version of it. So I have 2 root 2 CIS of 5 pi over 4. And those two answers boxed in green mean the same thing. It's up to you on if you want to write it out the expanded way or the condensed way. All right, let's do another one. So once again, I'm going to start by finding my r, which is the same thing as finding magnitude of a vector. So I have 6 squared plus negative 6 root 3 squared. Now, if you'll notice, when I'm finding my r, I am not putting I in the expression. I'm just using a and b. That b term is the negative 6 root 3. It does not include the I when you are trying to find your r. And I am plugging this into my calculator. 6 squared plus negative 6 root 3 squared gives me the square root of 144, which is 12. Okay, So now I have my r. The other thing I need to do is I need to find my theta, which once again is the same thing as finding direction. So to graph this, I have a positive A with a negative B, so that puts me in the 4th quadrant. So I want you to think of your A as your X and your B as the Y. There you go. And here's our little theta once again, still our reference angle. And then if you'll notice, once again, I have my opposite and my adjacent. So I have tangent of theta equals opposite, negative 6 root 3 over 6. Opposite over adjacent. And then I can go ahead and reduce this because I have my 6's. They can go ahead and cancel out. And since I'm solving for an angle, I'm going to do inverse tangent of negative root 3. And I am not quite sure what that is off the top of my head, so I'm going to trust my handy dandy TI-84 to figure it out. That's negative 60 degrees. I feel like I should have known that, but you know, I didn't. So 60 degrees. Now I don't really care that it is negative. I'm just going to use the 60 degrees as my reference angle. Now keep in mind, anytime we're talking about theta, theta has to come from standard position. So that's from your positive x-axis all the way around until you hit your complex number, similar to what we did with vectors when we were finding direction. So theta is going to end up being 360 minus 60, which is 300 degrees, which of course I have to change to radians. So I'm going to take 300, multiply it by pi over 180, and that gives me, man, my mental math skills are not good today. 300 over 180, I'm putting it into my calculator, 5/3. So 5 pi over 3. All right, so I have my r and I have my theta. I can go ahead and write my complex number in trig form. So I'm going to have 2 answers. I'm going to write the expanded version as well as the condensed version. So it's going to be my r times cosine of theta, which is 5 pi over 3, plus I sine of theta, 5 pi over 3. So that is answer number 1. The nice long version, and I also have my short version, which is 12 cosine plus I sine, so CIS of the angle, 5 pi over 3. And that right there represents your 6 minus 6 root 3i in trig form. Okay, so our first example is going from a complex number to trigonometric form. The second example is doing it in the opposite direction. So now we're going to start in trig form and get the complex number, because in math we always want to do things in one direction and then undo it by going in the opposite direction. So here we go. So right here I have my complex number in trig form already, and I want to express it in a plus bi form. So essentially what you want to do is you want to calculate these trig values. So I want to figure out what the heck cosine of 4 pi over 3 is and what sine of 4 pi over 3 is. So this is a nice little refresher on finding exact values of trig functions. So the first thing I need to do is I need to figure out where 4 pi over 3 is. So I'm going to graph it. So 4 pi over 3, in terms of radians, I have 0, pi, and 2 pi. But since this is in thirds, I'm going to write this as 3 pi over 3, and my 2 pi is the same thing as 6 pi over 3. And that's going to help me figure out what quadrant to graph 4 pi over 3 in. So 4 pi over 3 is past 3 pi over 3, so that puts my angle over here. So this is 4 pi over 3. I want to find my reference angle, so I want to figure out what this is. So I am 1 pi over 3 past 3 pi over 3. So there's your reference angle. And your reference angle is going to help us figure out the ordered pair from the hand trick. So we're going back to that hand trick. Okay. Since I am in the third quadrant, in my third quadrant, x is negative, y is also negative, so I'm going to adjust that accordingly once I do get my ordered pair. So, you can't see my hand, but I'm using my hand trick. Pi over 3 is my index finger, and my index finger, when I put that down, that gives me the ordered pair 1/2 and root 3 over 2. But since I am in the third quadrant, I need to go ahead and make both of those values negative. Now, if you have no idea what the heck I'm talking about, you may want to revisit, I believe it was chapter 4, 4.2. All of this stuff connects. Okay, so now that I have the ordered pair, cosine is my x, sine is my y. So I'm going to go ahead and rewrite my original problem. So I'm going to write this as 12 times cosine of 4 pi over 3 is my x-coordinate, so negative 1/2, plus I sine of 4 pi over 3. So it's going to be plus negative I root 3 over 2. Now, of course, you're subtracting a negative, so I'm going to go ahead and, or I'm adding a negative, so I'm going to go ahead and change that to a minus. Now that I have those ordered pairs, the cosine and the sine, my last step is to distribute this 12 into the parentheses. So when I take 12 and multiply it by negative 1/2, that gives me negative 6 minus, and over here, when I multiply, I'm going to go ahead and write it out so you can see what I'm doing. So that gives me 12i root 3 over 2, because you can just multiply your numerators. And then my final answer is negative 6 minus 12 over 2 is 6. So that gives me 6i root 3. And there is your final answer. Ooh, that's a doozy. Okay. Now for letter B, I have it in the condensed form. So I'm going to go ahead and start by expanding it out first. So I can write this as 5 root 2 times cosine of 7 pi over 4 plus I sine of 7 pi over 4. And just like with the last one, I need to figure out where the heck 7 pi over 4 is because I want to find the exact value of that trig function. So this is in fourths, so I have 0, pi is over here, but in terms of fourths, that's 4 pi over 4. This is 2 pi, but in terms of fourths, that is 8 pi over 4. 8 pi over 4. And 7 pi over 4 is closer to 8 pi over 4 than it is to 4 pi over 4. So that's going to put me right here in the fourth quadrant. And in the fourth quadrant, my x is positive, y is negative. And I need to figure out my reference angle. Here's my reference angle. So 7 pi over 4 is 1 pi over 4 before 8 pi over 4. Let me draw that visual. Going all the way around over there, that's the 7 pi over 4. And so I need 1 more pi over 4 to get to 8 pi over 4, so that's my reference angle. Once again, I'm going to use that with my hand trick. I wrote pi over 2. I meant pi over 4. There we go. Okay, so using that with my hand trick, pi over 4 is my middle finger, which of course you can't actually see what I'm doing, but that gives me root 2 over 2 and root 2 over 2. So since I'm in that fourth quadrant, my x is positive, y is negative. All right, now I just have to work through that lovely distribution, and I have run out of space. So let's see, what can I do? What can I do? Maybe I'll just write really small. I'm going to write really small. Here is my cosine. There is my sine. So I have 5 root 2 times root 2 over 2 minus, since my sine was negative, I root 2 over 2. So I'm just replacing my cosine of 7 pi over 4 with this root 2 over 2. And I'm replacing my sine of 7 pi over 4 with this negative root 2 over 2. And then from here, my job is to multiply. Now I'm going to show you every little detail of what's happening here because there's a lot to process with all the radicals. So 5 root 2 times root 2 over 2. That gives me 5 root 4 because I can multiply what's inside the radicals over 2 minus Same deal over here. So 5 root 4. Forgot my I. I'll just shove my I over here, over 2. All right, but what is the square root of 4? Square root of 4 is 2. So I have 10 over 2 minus 10 over 2i, which of course can be reduced. 5 minus 5i. And there is your final answer. Okay, now what if you went through this entire process and you're like, oh my goodness, I cannot figure out what this lady is talking about. Let me give you a shortcut. You're more than welcome to plug these into the calculator. Just make sure your calculator is in radian mode. Why didn't you tell me this before? Because I like to show you all the little details beforehand. And then what you can do in the calculators is you can calculate these individual trig functions one at a time. So if I put my calculator in radian mode, and which I'm actually doing right now, but of course you can't see, and I type in cosine of 4 pi divided by 3, that gives me negative 0.5, which of course we know is negative 1/2. Now, if you're going to use the calculator as a shortcut, a couple things that you need to remember. Negative 0.5, because it's going to give it to you as decimal. So negative 0.5, of course, we know is negative 1/2. Now, your calculator could also give you this as an answer, 0.866. That is an approximation for root 3 over 2. And our other approximation is 0.707, and that is root 2 over 2. So if you want to skip all of this stuff, you're more than welcome to do so. What's going to happen is when I take cosine of 4 pi over 3, it's going to take me straight to negative 1/2. When I take sine of 4 pi over 3, you're not going to put the I in the calculator, it's going to give me a decimal. So when I do sine of 4 pi over 3, that's going to give me negative 0.866. But if I look over here, 0.866 is approximately root 3 over 2. So then I can just go straight down here and write negative root 3 over 2. All right, so as I was saying, you're more than welcome to skip this step if you want to. You can use these little shortcuts in the calculator if you know the decimal approximation for the exact values of the trig functions. All right, so that concludes our little lesson for today, trig form of complex numbers.